Alright, let's remind ourselves of the Cramers rule. How does that work? If you have a matrix with A, B, C, D, E, F, G, H, I with L, M, N, X, Y, Z, you have a system like this, then you get the value of X by taking the, if I call the determinant of this by capital D, you have to compute the determinant of a new matrix by substituting the first element by this row of constants, column of constants. So L, M, N replaces the first column, and the rest is the same. That's how you get the X. And then for Y, instead of doing for the first column, you replace the second one. So it'll be A, C, D, F, G, I. The second one would be L, M, N, and divide by D. And then for the Z, you do it to the third one. Okay? So that solution is called the Cramers rule, which is handy if you have system of equations, especially with some coefficients being a non-number. So let's try that. First, if I write that as a matrix, matrix equation is 3, M, 0, M plus 1, 0, negative 2, 0, 1, negative 1, X, Y, Z equals to 1, 3, 2. Now, because we have the D in the denominator, we definitely need the determinant of this. So let's try that. 3, M, 0, M plus 1, 0, negative 2, 0, 1, negative 1. You can opt to use the row expansion or column expansion, or you can take this other method. I don't really know which is faster. I think when I'm doing it alone, I just do the row expansion, but showing it on the board this is faster. So that's 0, that's 0, that's 0. Oh, everything's 0 here. That's 0. That's negative 6. That's negative m times n plus 1. And then you have to do right minus left, so you end up with 0 minus, the right is just 0, minus negative 6 minus mn plus 1. So that becomes 6 plus mn plus 1, which is same as m squared plus m plus 6. So that's our determinant. Now, in order to get x, you need the determinant of the matrix obtained by replacing the first column by the constants, right? So you have 1, 3, 2 replacing the first one. M, 0, 1 stays the same. 0, negative 2, 1, negative 1 stays the same. Let's try the same method. Copy 1, 3, 2, M, 0, 1. And then do this. 0, negative 4m, and 0. 0, negative 2, negative 3m. And then you do right minus left, so it's negative 4m minus negative 2 minus 3m, which is positive 3m, so it's negative m plus 2. Okay? So we now have the value of x. What is x? X is the ratio between this one over that one, right? It's this matrix over the determinant D. So I say x is negative m plus 2 over m squared plus m plus 6. In the same way, let's go for y. Y, you do 3, m plus 1, 0, and then 0, negative 2, negative 1. That's same, but now the middle one is replaced by this. 1, 3, 2. And then 3, m plus 1, 0, 1, 3, 2. Do this, this, this. These are zeros, but this one is negative 9. This, this, this. Okay, so this 0, negative 12, negative m plus 1. And then right minus left, so you get negative 9 minus negative 12 minus n plus 1, which is negative 9 plus 12, that's positive 3. plus n plus 1, this n plus 4. Therefore, we have y as m plus 4 over m squared plus n plus 6. Okay. And then finally, for z, y is not equal to this matrix, sorry. Y is equal to this over d. I shouldn't write that. All right, z is, for z, we need the matrix 3, m plus 1, 0, m, 0, 1. And then you do 1, 3, 2. Again, copy down the first two columns. Zero, 0, m plus 1, 0, 9, 2 times m plus 1. And we have to do right minus left, so that's m plus 1, that's the right one, minus 9 plus 2m, m plus 1, which is m plus 1 minus 9 minus 2m squared minus 2m. So if you simplify, you get negative 2m squared minus m minus 8. Therefore, z is negative 2m squared minus m minus 8 over m squared plus n plus 6. So that's how you solve it by Cramers.